So what I want to do is show you how to get this thing called Ax plus By equals C form of the equation of a line. And I want to tell you why, even though it's a short video, this is a very important part of what we work on. And that is, Connect Math is going to put you through something where they say, hey, why don't you just use this formula? Just memorize this formula too, and everything's going to be great. Okay, you saw that I did actually memorize at some point in my life. But I'm going to show you briefly how to use that in a future video that I give you. But if you're really good at this, you won't ever have to learn this, use this, or do anything with it. But I want you to be familiar with that. Okay, that's called point slope form of a line. Connect Math relies on it because they figure, hey, I'm already asking them to memorize something. Why don't I ask them to memorize something more? And that's a little crazy because we're going to do y equals mx plus b and really get good at that and use that to solve all the problems that we have. The only thing that we need is to understand what we're going to do here today. And today that is to get the ax plus by equals c form of the equation of a line. Very important is this a, b, and c are capital. It's not just me showing off or saying, hey, I know something you don't know. These mean that they are coefficients rather than variables. The capital A, the capital B, capital C are coefficients. So they'll be numbers. You could even have it be like a1, b1, and c sub 1, right? Those things. But x and y will stay there as letters. What's going on here is, though, the deal is if those are capital letters, they're going to be integers. You will not have a fraction anywhere in the equation of a line in ax plus by equals c form. Quick aside, some teachers will call it the standard form of the equation of a line. That is not true. The standard form of the equation of a line does have a look like this, but also it's got a case where c is as small as possible. That still does the job. So don't hear that as the standard equation. Ax plus by equals c allows for a lot of bigger sets of numbers to fill the job of getting this done. So because these are capital, this, which is ax plus by equals c, is a different b than this lowercase b. Not just because we write it differently, but because we have this is a y-intercept. Now is a good time for me to tell you why that's called b, because the word intercept doesn't have the letter b in it anywhere. There's another intercept called the x-intercept. The x-intercept comes up as an x value that shows up in front of a 0, so it's first. We give that the a, followed by a 0. The y-intercept is a b because it's second in its pair. We don't want it to be a. It's not going in the first spot. It goes in there for b. That's why it's called b. Otherwise, it doesn't make any sense. They're just math teachers being mean, saying y equals mx plus b. Why don't they use letters that mean something? That's where that comes from. Now, into this. What happens is when we have y equals mx plus b form, something like this, put these equations of lines into capital A lowercase x plus capital B lowercase y equals c form. Here are the steps we're going to use. So what's going to happen is I want you to be able to do y equals mx plus b, get all the work done, and get it so y equals something in the equation of a line from which we can draw slope and the y-intercept information. Awesome. We're going to get solid at that. We're going to do lots of practice and work on that. Then you don't have to use that other form, point slope, because you go ahead and use your slope-intercept, get the equation of a line, and then you might get stuck with the answer of your work coming out like this. And our job is to get it ax plus by equals c, which means it's going to be an x, then a y, then an equals, and then a number in that order. Our job first is to clear fractions. If there are fractions in here, we can't have fractions staying around. Then we would multiply by a number large enough to get all the fractions cleared. Normally, we'd use the LCD, but any number that does all the canceling by hitting all three of those terms with a multiplying factor is going to work. All right, this one doesn't have any fractions, so we don't need to do step one. We don't have to clear what is not there, right? It's all set. Now we're going to isolate the constant, which means we need to have the 11 come alone. Now what I'm thinking as I'm doing this is I've got y equals negative 3x plus 11, and that means that I have 1y. In case I need it later, or if I have to multiply, it's good to have the 1 there. I need to have x, then y, then equals, and then the number. But I have y equals x and then the number. One of them is in the wrong place. And what happens is if the x was over here instead of over there, I would be good. So I need to get the x over on this side. I'm going to add 3x to both sides, and I'm going to put it out in front of the y, so that when I do add nothing to 3x, I get 3x, add nothing to 1y, I'm going to get 1y, equals, this is gone, 11. That gets me 3x plus y equals 11. The 1 could be in there with no problem. Turns out capital A is 3, capital B is a 1 that you don't see, and C is 11. And that's done, because now it's got x, then y, then equals a number with no fractions. And that is getting us into that standard form. So if you get good at this, then you don't need to learn that other format. You just need to finish off your equation if it wants it to look like this by doing those things. Get rid of fractions, isolate C with the x, then the y, and then the number after the equal sign. Here's another one. Y equals -4/5. Why? Is it because it's negative? Probably not. Because of the fraction? Probably. -11/5. All right, we want to get that one into the format that we need. So let's see what we've got. We've got 1y, and I'll leave space between the 1 and the y, because sometimes there's a number there that's not 1, so we need that, but 1 there, equals -4/5 with space before the x, plus -11/5 with space behind it. I need to clear these fractions. Now, clearing fractions is something you need to learn. You're like, oh, I hate that. Clearing fractions makes fractions go away, actually getting rid of what you hate. So, come on. What we're going to do here is we're going to look for what we can cancel the 5s with, right? The denominators are the things we have to cancel. We have to get rid of that 5, that 5. We need something big enough as a multiplier to make sure my 5s will cancel. You might be thinking 25, and that won't be wrong. It won't be perfect, but it'll get ax plus by equals c to meet the criteria that it wants to. What we're going to do is we're going to multiply each of these by a number that's going to cancel a 5. I don't have to worry about the 1 canceling. So what's going to happen is 1 becomes 1/1, and what I need to do is decide what the LCD is. Now, if you're thinking you're going to use 25, I'm going to tell you that's not going to get you into trouble. The numbers will be bigger than they need to be, but how about 5/1? 5 will cancel the 5, 5 will cancel the 5, and we drop in a 5/1 as a multiplier times each of our existing terms. And what we're going to find is that this 1 doesn't need canceling, but 5 divided by 5 is 1, the blue 5 divided by 5 is 1. This black 5 divided by 5 is 1, the blue 5 divided by 5 is 1. We now have no more fractions, because when we go through, we're going to come out with this. 1 times 5 times y, that's 5y, equals -4 times 1 with an x. -4 times 1 is -4, with an x is x, plus -11 times 1 is -11. And they're all over 1, so there's no more fractions here. We've now cleared the fractions. It's still not perfect, because it should be x, then y, then equals, then the number. This is the guy in the wrong place, so I'm going to add 4x to both sides. I'm going to put the 4x in front of the 5y, and I have 0, nothing plus 4x gets me 4x, plus 5y with nothing extra is 5y, equals, this is gone, and it's -11. Now, you might find that you don't like this. You should learn it. You might find that that doesn't seem very hard. That's awesome. You should learn this and know how to get rid of fractions, multiplying by the LCD, and how to get it to isolate the number term so we can get it in this form. And if you do that, you'll be able to do all the work learning and only knowing y equals mx plus b, which is great.